We're starting chapter 15, which is probability rules, which is all about probability, and really talking more about probability rules. But we have the exclamation point, which is supposed to show excitement. So we're going to talk about events first. An event is any set or collection of outcomes. If you flip a coin, the sample space is all the combinations of possible outcomes. So flipping a coin in this case is heads and tails. Those are your possible outcomes, so that is your sample space. Let's take an example. So if you pull a bill from your pocket, the sample space is going to be all the bills that are currently in circulation. So in this case, it would be a 1, 2, 5, 10, 20, 50, and 100. Twos are rare, but they are still in circulation. We can combine possible outcomes into events. For example, event A could be a 1, a 5, or a 10, and event B could be a 10 and a 100, which are bills that don't have the face of a president on them. And then we have event C, which is a 25 and 100, which are bills that you could use one bill to pay a $12 bill with. And event A is just going to be the most common bills that we'll have. Each of these events are not equally likely, and we cannot calculate the probability of such events unless we know the probability of each outcome. It is more likely that somebody will have a 5 or a 10 in their wallet than having a 50 or a 100. When outcomes are equally likely, probabilities for events are nice and easy to find. For any event A that is made up of equally likely outcomes, the probability of A is the count of the outcomes in A over the count of all possible outcomes. This brings us to the general addition rule. The general addition rule states that you add the probabilities of the events and then you subtract out what they have in common. So using the proper notation, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. For an example, what is the probability of picking an odd bill? So event A is going to be the odd bill, which is a 1 or a 5. Or we pick a bill with a building on the back of it, which is a 5, 10, 20, 50, and 100. In both situations, getting a $5 bill is an option. This means that they are not disjoint. They overlap. They share an outcome in common. The 5 is in both A and B. So this is how we would calculate the probability of getting an odd or a building. The best way to go about figuring this example out is going to be with a diagram. Again, the first 3 rules of probability are make a picture, make a picture, make a picture. In this case, I'm going to make a Venn diagram. So we have our sample space, which is the overall box, and then we're going to have event A and event B. In event A and event B, both options of having a 5 is an option. If I call this event A over here, then 1 and a 5 is an option. So a 1 would also go in that circle. If this is event B, well, event B has a 5, 10, 20, 50, and 100. We already have the 5, then we would have 10, 20, 50, and 100. Now, there is a bill missing here, which is a 2. And a 2 doesn't fit into event A or event B, so that goes on the outside, but it's still within our sample space. When you are making a Venn diagram, you always want to put what both events have in common in the center first. Then you put what is left over inside of the circle, but on the outside of the center. Because event A is a 1 or a 5, and event A is this whole circle here. So we have a 1 and a 5. And event B is a 5, 10, 20, 50, 100. And event B is this circle here. So in both cases, we're still including everything within each event. So what we would do here to calculate the probability, using the proper notation, we have the probability of an odd plus the probability of a building minus the probability of both. So odd is going to be 2 out of 7. So, because there's 2 inside of that red circle. plus the probability of a building. There are 1, 2, 3, 4, 5 out of 7 in event B, minus the probability of both. Well, both, that green 5, fits into both categories, so I subtract out that one option out of 7, leaving us with 6 out of 7. The other way that we could do it in this particular case is we can count up how many options there are total. So the 1, 5, 10, 20, 50, 100, and 2 make 7 options. Then we can count how many are in the boxes or the circles all together, which is a 1, 5, 10, 20, 50, and 100, which is 6, and where we come up with 6 out of 7. But this would be our final answer. Another example is that police report that 78% of drivers stopped on suspicion of drunk driving are given a breath test, or a breathalyzer. 36% are given a blood test, so in this case they're taken to the hospital and somebody draws their blood for testing, and 22% will receive both a breathalyzer and a blood test. We want to know what is the probability that a randomly selected DWI, driving while intoxicated, is given a test, so either test, a blood test or a breath test, but not both, or neither test. With this example, again, my first step would be to draw a Venn diagram, or some type of picture, but in this case a Venn diagram is going to be best. So we were told that drivers are either getting a breath test or a blood test. So let's make the probability of a breath test equal A. So that'll be event A. And we'll make the blood test event B. To make a Venn diagram for this situation, we have two scenarios. Event A and event B. So we know that 78% get a breath test, 36% get a blood test, so let's write that, 78, 36, and then 22% get both. Again, when you're making a Venn diagram, you want to put what they have in common in first, so 22 goes in here. Then, if this is event A, so this is having a breath test, well, the total that get a breath test is 78, but I already have 22 in here. So I need to take 78 minus 22, where I come up with 56, and that goes on the outside, because 56 plus 22 is at 78. For the blood test, we have a total of 36. Well, we already have 22, so again, we need to subtract 22 from 36, where we end up with 14, because the breath test is this whole circle here, or blood test, excuse me, and we end up with 22 plus 14, which is the 36 we're supposed to have. Then, to figure out what is on the outside, because not every person who is stopped is given a breath test or a blood test, I can add these three numbers up and then subtract them from 100. So in that case, we would end up with 8. So 8% goes on the outside. Now, this means that when they wanted to know the probability that a driver is given a test, they're not specifying. It can be a blood test or a breath test. So the proper notation for this would be the probability of event A plus the probability of event B minus the probability of A and B. So we could calculate it as 78 plus 36 minus 22. Or, what I find easiest is to just add the numbers in the circles. 56 plus 22 plus 14, which ends up giving you 92%. Now, to find the probability of a blood test, which is event B, or a breath test, event A, but not both, we would just add the 56 and the 14. So this would be 56 plus 14. So this would end up equaling 70%. And then the last question they asked the probability of neither test. Again, if you use a Venn diagram, we can easily see that it's what's on the outside of the circles, so 8%. Otherwise, you would do 1 minus the probability of A or B. So 8% would be our final answer. That is all I have for today. I'll see you guys in class on Monday. Have a good one.